Okay, adding rational expressions. First, we need to find out what the common denominators are. So let's look at the denominator for x. So you have an x to the fourth here, and over here, this one has an x squared. When you look at the multiples for x to the fourth, you have x to the fourth, and there's x to the fifth, x to the sixth, x to the seventh. For x squared, you have x squared, x to the third, x to the fourth, and x to the fifth. What they have in common in their multiples will be x to the fourth, which is the highest power. Okay, we can do the same with the x plus 3, that little binomial that starts off to the second power here, and over here, x plus 3 starts off to the third power. So the multiples of this will be x plus 3 to the second, then x plus 3 to the third, x plus 3 to the fourth. The multiples for this one will be x plus 3, next will be to the fourth, and then x plus 3, and next will be to the fifth. And then what's common is the x plus 3 here. So let's take a look. We have 4 and 1 as numerators, x to the fourth plus x plus 3, and that's to the second. And this is x squared and x plus 3 to the third. Now let's find the common denominators. We'll put the 4 here and the 1 there. So we have an x to the fourth and x squared. Now what's common in their multiples? The least common will be x to the fourth, which is the highest power. So we'll put x to the fourth here and x to the fourth there. So they both have it. Okay, so here we have x plus 3 to the second power and x plus 3 to the third power. What will be common will be x plus 3 to the third power. So that'll be the least common multiple. So x plus 3 to the third power and x plus 3 to the third power. Now, let's find out differences. Here we have x plus 4, x plus 4. So there's no extra x plus 4. Sorry, there's no extra x's, should I say. X to the fourth, x to the fourth. Here we have x plus 3 to the second, x plus 3 to the third. So there's an extra x plus 3 in the denominator. So we're going to put an extra, just one extra x plus 3 in the numerator. All right, here they have an x squared here, but an x fourth. So there's 2 extra x's in this denominator. So the numerator needs 2 extra x's. So we'll put 2 extra there. The x plus 3's, there's 3 of them there and 3 over there. So there's no extra. So let's find out what the denominator is. X4, x plus 3, and to the third power. Okay. So we're going to take this right here. Now, anytime you have a first power on an expression, you can distribute the outside number. So we're going to take the 4, and we're going to multiply the 4 with the x and the 4 with the 3, and that'll be our distribution. So we'll have a 4x and a 12, okay, after distribution, and a 1x squared. And again, if you don't write the 1, it's still going to be correct. So 4x, a 12, and a x squared. Next, for this one, we're going to rewrite it. We have a 3 for the numerator, a 2, here an x, and x minus 5 to the fifth power. Here we have an x cubed, and an x minus 5 to the sixth power. All right, so let's find out what the least common denominator is going to be. We'll put the 3 here and the 2 there. All right, so we have an x here and an x to the third there. What's going to be the LCD will be the x to the third. So we're going to put it in both places. X to the third and x to the third. Here we have x minus 5 to the fifth, x minus 5 to the sixth. What's the least common of these two denominators will be x minus 5 to the 6th. So we'll put it both places. X minus 5 to the 6th, x minus 5 to the 6th power. Now see the difference between the two denominators. Here we have 1x, here we have 3x's. So 2x's have been added. So let's add 2x's to the numerator. Over here we have a x minus 5 to the 5th and x minus 5 to the 6th. So we have one x minus 5 that has been added to the denominator. So we'll add one x minus 5 to the numerator. Here we have x to the third, x to the third. So no x's have been added. X minus 5 to the 6th, x minus 5 to the 6th. So nothing's been added there. Okay. So now we can write everything with a common denominator of x to the third, x minus 5 to the 6th. Now, this binomial is to the first power, which means that we can distribute the 3x squared into the x minus 5. So 3x squared multiplied with the x together multiplies to an 3x to the third power. And when you multiply the 3x squared with the negative 5 over here, that'll give you a negative 15x squared. Now we can write the plus and the 2. So plus and the 2, and we are finished. Okay, number 6. Number 6, we have a 2 and a 1 for the numerator. We have an x here, x plus 2 to the 4th power, and an x to the 4th power here, x plus 2 to the 3rd power. All right, so we're going to find the least common denominator for both of these. So let's put the 2 and the 1 here and here. So you have x here and an x to the 4th. What's common is x to the 4th. So we'll put an x to the 4th in both. X to the 4th here, x to the 4th. All right, we have an x plus 2 to the 4th and an x plus 2 to the 3rd. What's common will be the x plus 2 to the 4th. So we'll put that both places. X plus, oops, bad looking, plus x plus 2 to the 4th. Over here, x plus 2 to the 4th. Now, let's find out what's new. We have an x here and an x to the 4th, so there's additional 3x's. So we'll put an additional 3x's here. Now here we have x plus 2 to the 4th here, x plus 2 to the 4th. That's a bad looking plus, but there's no extra x plus 2's. We're good. Here's 4x's here, 4x's there, nothing extra. But here we have x plus 2 to the 3rd, here x plus 2 to the 4th. There's one extra x plus 2 in the denominator. So we'll put one extra x plus 2 in the numerator. Okay, so now we got our common denominator, x to the 4th, the x plus 2 to the 4th. Now, 2x cubed is 2x cubed, nothing happens, then the plus. But over here, we have distribution. We have a 1 that can be multiplied with the x, and a 1 that can be multiplied with a 2 because of the binomial here, x plus 2 to the first power. So 1x times x is 1x, and 1 times 2 is 2. And we are finished. If you don't write the 1, it's still correct, whether you have 1x or x.